Okay, you guys, continuing video number 3. Obviously, I'm having technical difficulties. Thanks for being patient. What I want to talk about is what we call mole conversions. So let me start by telling you, in mole conversions, the best way to think of this is you've got 3 cities. Okay, you've got your mass city, you have your mole city, and you have your atoms or molecules city. So we got 3 cities here. Okay, so we've got 3 cities here. The only way to get from city to city is to take certain highways. Okay, so if I am going from mass to mole city, the highway I'm going to jump on is called the molar mass. Molar mass highway. If I'm going to go from mole city to atoms or molecules, I'm going to have to hop on Avogadro's highway. And if you guys remember, Avogadro's number is equal to 6.022 times 10 to the 23rd. If I need to get from atom or molecule city back to mole city, I'm going to have to jump right back on Avogadro's highway, which is, again, 6.22 times 10 to the 23rd. If I need to go from mole city back to mass city, I'm going to have to jump on, again, the molar mass highway. So if I am converting from mass to moles or grams to moles, I have to jump on the molar mass highway. Where I'm going to find the molar mass of any element or compound is using the atomic weights on the periodic table. If it is an element, I'm going to take the atomic weight and label it in grams, and that is going to be my conversion factor to get from mass to moles. If it is a compound or molecule, I'm going to have to use all of the elements' molar masses and add them together to get my conversion factor. So this is the best way to think of it. If I'm converting from grams to moles, I jump on the molar mass highway. I am going to use the periodic table of elements to make my conversion factors. If I am going from moles to atoms or molecules, I'm going to jump on Avogadro's highway, and the number I am going to always use is 6.022 times 10 to the 23rd. Okay? And again, if we're going in the opposite direction, if we're going from atom or molecule city to mole city, I'm going to jump on the Avogadro's highway and use that 6.022 times 10 to the 23rd. And if I'm going from moles to mass city, I'm going to jump on that molar mass highway, which is going to be found on the periodic table of elements. So let me give you some examples of how we're going to do this. We are going to take our molar mass and we will turn it into a conversion factor. And we will take our Avogadro's number and we will turn that into a conversion factor when we need to do these conversions. So let's just get started. Okay. This is on your periodic table. Let me see if I can unzoom this so you guys can read it a little bit. Wow, technically, I've got serious technical difficulties. Okay, so you have a container which contains 2.65 grams of iron pieces. How many moles of iron do you have? Okay, so this is a very small conversion. So it tells us that we have 2.65 grams of iron. Grams of iron. Now, we have to get from grams to moles. As you can see, it says moles right here. So, in order to go from mass to moles, we have to jump on the molar mass highway. So this is what I'm going to do. I'm going to set it up like any sort of dimensional analysis problem. And I am going to go to my periodic table. I'm going to find the molar mass of iron. I'm going to, again, round it to 2 places past the decimal. So 55.84 grams per mole is the molar mass of iron. So I'm going to split this up. 1 mole of iron is equal to its mass in grams, which we saw on the periodic table, as 55.84 grams. This whole conversion factor represents the molar mass of iron, okay? So if you guys remember, I could write it out like this. 1 mole of iron is equal to 55.84 grams of iron. So we are just taking this equality, okay, which is the molar mass of iron, and we are putting it into a conversion factor, just like we did before. Now, again, converting, we round to however many sig figs we start with. So 2.65 divided by 55.84 is equal to 0.0474 moles of iron. That's just a small conversion. Okay, so let's take a look at our next problem. See if I can zoom this out again for you guys. Wow. If you guys aren't sick by now, you will be at the end of this. Okay, here's our question. It says your bottle of water is half full. It contains 15 moles of water. What mass in grams of water do you have? Okay, so we are starting with 15 moles of water. And we have to get to mass in grams. So we are going to jump on the molar mass highway. So again, I'm going to have to find the molar mass of water. Now, I've got more than one element, so I have to actually calculate that. So down here off to the side, I would calculate the molar mass of water. And we already actually did this. So we have 2 hydrogen atoms, each at 1.01, 2.02. We have 1 oxygen at 16.00 to give us 16.00. We add those together, 18.02. So we've just calculated the molar mass of water. So basically, I have 1 mole of water is equal to 18.02 grams. So I'm going to take this equality and I am going to put it into my conversion factor. Whatever I want to get rid of goes on the bottom. So 1 mole of water is equal to 18.02 grams of water. So now I'm going to cancel my moles out. I'm going to multiply straight across. Looks like we're starting with 2 sig figs, so I want to end with 2 sig figs. So 15 times 18.02 is equal to 270 grams of water. So in order to do both of these conversions, we went from moles to mass, and this one mass to moles. We had to use the molar mass highway. If it is an element, you take it directly off the periodic table. If it is a compound or molecule like H2O, you actually have to calculate it before we can do the conversion. So let's look at another one. Okay, so you left your bicycle out in the rain over the weekend, and it accumulated 5.78 grams of iron 2 oxide. That's what FeO is. How many molecules of FeO were left on your bicycle? Okay, so this one's a big one. We are given grams, and we need to get to molecules, okay? So we're going to start with what we're given. So 5.78 grams of iron. Now, the only way to get from grams to molecules is we have to take a stop in mole city. So we actually have to go from mass to moles, and then moles to molecules. Okay? We say molecules because this is actually a molecule, or it's a unit, or it's a compound. But we wouldn't normally label something as compound. We would label it as molecules. So we actually have a bigger problem than we did before, as in a larger, not problem, but more work to do. So we're going to have to go from mass to moles and moles to molecules. So we're going to use the molar mass highway to get us from here to here. And then we're going to use Avogadro's highway to get us from here to here. So let's get started. So I got to jump on the molar mass highway, and in order to do that, I got to go to the periodic table. Oh, that's FeO. Sorry about that. Okay, so we got to actually calculate our molar mass. We have iron and we have oxygen. Okay, so I'm going to come down here and calculate the molar mass of FeO. So Fe, we only have one atom of iron at 55.85. I'm getting that off the periodic table. We have one atom of oxygen at 16.00. Okay, so I'm going to add these two together. 55 point, is it 85 or 84? Let me double check. It's 55.84. Sorry about that, guys. It's that darn 5 rule. Okay, so 55.84 plus 16 will give me 71.84 grams. So what we calculated is we just calculated the molar mass of iron 2 oxide. So basically 1 mole of FeO is equal to 71.84 grams. So now that we have our conversion, or our equality, we can stick it in our conversion factor. We can say 71.84 grams of FeO is equal to 1 mole of FeO. So our grams of iron 2 oxide cancel out. But we're sitting at moles, but we really need to get to molecules. We got one more step to go because it says how many molecules of FeO. So we're going to go one more step, and right now we're in mole city, and we've got to get to atoms or molecule city. So this is where I'm going to jump on Avogadro's highway. So 1 mole of anything, in this case it's FeO, is equal to 6.022 times 10 to the 23rd, and this is molecules of FeO. Our moles cancel out, and I'm going to just multiply everything straight across and divide by whatever I have in the bottom. So in my calculator, I'm going to put 5.78 times 6.022 times 10 to the 23rd, all divided by 71.84. is equal to 3 sig figs, 4.84 times 10 to the 22nd molecules of FeO. So if I started with 5.78 grams of rust, basically, and I wanted to figure out how many molecules of rust I have in this mass, then I convert to moles, and then I convert to molecules to give me 4.84 times 10 to the 22nd molecule. Okay, let's look at this next problem. If you need 2.57 times 10 to the 18th atoms of sulfur for an experiment, okay, what is the mass in grams of sulfur needed for the experiment? Okay, so we are starting with atoms, and we have to get to mass. So we're basically doing this in the opposite direction. So I'm going to start with what I'm given, 2.57 times 10 to the 18th atoms of sulfur. Okay, now so we're doing this in reverse, okay? I'm going to make this atoms. So we're given atoms. We're going to have to jump to mole city on Avogadro's highway, and then we're going to have to get from moles to grams on the molar mass highway. So we're doing this problem just in reverse with sulfur. So we're starting with 2.57 times 10 to the 18th atoms of sulfur. So I've got to get from atoms to moles, so I'm going to jump on Avogadro's highway. So 6.022 times 10 to the 23rd atoms is equal to 1 mole, and this is sulfur. And my atoms cancel out, and I'm sitting at moles, but I don't want to stay at mole city. I got to jump over to mass city, and I'm going to do that by jumping on the molar mass highway. So I'm going to say 1 mole of sulfur is equal to sulfur's mass in grams. So right here, sulfur 32.06. So 32.06 grams. Okay, so moles of sulfur cancel out. And now I'm going to multiply everything straight across the top and divide by anything I have on the bottom. Just exactly what we did in chapter 2. So 2.57 times 10 to the 18th times it by 32.06 divided by 6.022 times 10 to the 23rd. Again, I'm going to want 3 sig figs, so my answer is going to be 0.000137 grams of sulfur. Not even 1 full gram of sulfur. Okay, let's do one more. Okay, let's do number 2 down here. It says, your aluminum soda can has 1.81 times 10 to the 24th atoms of aluminum in it. What mass in grams of aluminum do you have? Okay, so we're starting with atoms of aluminum. So we're starting with atoms, and we have to go through moles in order to get to mass. So we're going to do just that. 1.81 times 10 to the 24th atoms, and this is of aluminum. So we have to we've got to go to the mole city, so we have to get to Avogadro's highway first. So 6.022 times 10 to the 23rd atoms of aluminum is the same as 1 mole of aluminum. Those two are equal. That's why we can split them up and put it on my conversion factor. Again, these two units always have to match, okay? So you'll always have to have, if you're going from atoms to moles, Avogadro's number is always going to be on the bottom. Got one more step to go. I want to get to mass city, so I got to jump on molar mass highway. So 1 mole of aluminum is equal to its mass in grams. So I'm going to go to the periodic table. There we go. Aluminum, 26.98. So 1 mole of aluminum is equal to 26.98 grams of aluminum. And now I'm just going to do the math. I'm going to multiply everything straight across the top, divide by anything I have on the bottom. So 1.81 times 10 to the 24th times by 26.98 divided by 6.022 times 10 to the 23rd. Again, I'm going to stick with my 3 sig figs, so I'm going to end up with 81.1 grams of aluminum. Okay, you guys. So this is something that you should definitely not freak out about. When I come back and I see you, we'll do a lot of practicing. I have on our schedule to do some whiteboarding. This is just dimensional analysis, exactly what you guys did in chapter 2, and many of you knocked it out of the park. We're just using different conversion factors than you're used to. We're using Avogadro's number, and we're using the molar mass. Okay, be good for the sub, and I will see you on Wednesday. Take care.